Thank you. So I'm Vivek Srivastava. I'm a product manager for machine learning at Workday. 9 months ago, I was a lead software engineer building machine learning data pipelines. So I switched to the dark side or the business side. And my partner in crime is Zhang. He's a lead machine learning scientist also at Workday. So today we're going to talk about this really long title, Document Understanding through Multi-Stage ML. We'll break all these things down. Before I do that, how many of you know or have used Workday? Okay, so some of you have. So for those who haven't, Workday is an enterprise company. It's an enterprise cloud company that provides a whole bunch of HCM, finance, and analytics solutions for other enterprise customers in the cloud. So say you want to file for PTO, simple things like that, or you want to file an expense report, right? Before Workday, you would have to go through a lot of paperwork, get all that going. So Workday sort of made that all available as a one-stop solution in the cloud. So, see which is the next button.
I'm the one on the right.
Oh, this one?
Yeah. If it's not. It's fine. Okay.
It's fine. I'll just use this. Yeah. So we'll talk a little bit about the use cases that we are solving today using machine learning at Workday. We'll talk about the solution we adopted. Henry will go into the details of the model and the algorithms towards solving these use cases. We'll talk about the results we've achieved. And we'll also talk about how this actually runs today in the Workday product. So we'll go a little bit into detail of productization of this feature. And then what were the key learnings from it? So
I know Workday has bought lots of companies along the way. So you're referring to the standard Workday product? Or
yeah.
Which exactly are you?
Yeah, I'll talk about that. Yeah. So essentially what we like to call within Workday is this whole ML application lifecycle development, right? You have this typical software development lifecycle. This is the whole ML application lifecycle development. So let's talk a little bit about the use cases that motivated the problem that we were going to solve. So in early 2017, some of our customers came to us and said that, we like that we have this expense report filing thing, we upload the receipts, and we go manually enter the amount, the date, the merchant name, and all of those details. But we have these sales guys who travel, and they have like these bunch of receipts at the end of every month, and it's a pain for them to do that. So a typical filing of an expense report has so many stages involved, right? So this is a typical business process that goes on in your company. You as a user probably are not aware because you just submit the report and you're done. But the manager has to review it, an accountant has at the end of the month reconcile that, and then process, and then the check comes to your direct deposit to your bank. What we got from our customers is that employees were losing paper receipts, they were not submitting receipts in time, and on the process side, a lot of our customers' accounting teams had a lot of problem reconciling some of these amounts because the receipt will show something, the employee enters something else. There was a kind of a mess. So this was kind of one of the pain points that we wanted to solve using machine learning. The other use case that we wanted to tackle is basically invoice automation. So every company has an accounts payable department. Their main job, right, among lots of other things, is to receive invoices, issue invoices, right, and reconcile all of that. So the first step is let's scan the invoice, validate all the data fields in that, route it to the right accounting team within the department, review it, put in the exact cost center code, get it approved, and then archive it as integrated into your general ledger account. So Workday does all of these things, but as you can see, this is a lot of manual steps. So the goal was to sort of automate this business process as much as possible using machine learning along the way. So we'll talk about how all these documents, maybe receipts, maybe invoices, and certain other use cases that we are currently researching on in Workday, like transcripts, because Workday has a student product, resumes, so Workday has a recruiting product, or it could be, so I'm blanking on some of the other documents that we get. So some of these other documents, the goal is to sort of build a common machine learning backend that can take any kind of document, right, apply some business logic to it, and extract feeds of relevance. That's kind of the high-level objective. So let's get this.
Okay.
So let's go through, before we go into the technical details, let's go through a quick demo of what we have today in production. And this is a simple use case, which is the first one, which is automating receipt scanning. So let's go through it. So it's not as cool as the portal demo because this is me talking, so some of you may fall asleep. But we'll see. So
today you're going to see how Workday has adopted machine learning in the main product to simplify and automate some of our users' workflow. Particularly, we'll focus in the area of filing expense reports. A significant number of our users use the Workday's mobile app, which you're seeing on the screen right now, to submit expense reports. So let's see how using deep learning, they have basically automated populating certain fields where the receipt is uploaded by extracting these fields from the receipt so that the user does not have to manually enter these values. So I'm going to show you a quick demo of filing a report using the cost per receipt. So the first thing you do after you log into the Workday mobile app is to click on the Expenses tab, and you do Scan Expense with Camera. And then we will choose specifically a receipt. So we have a cost per receipt, which I have on my phone. So we're uploading the receipt to our machine learning service. And now you will see that the receipt is actually being scanned. So we are actually in the back end running an ensemble of multiple deep learning models in order to basically do three main things with the receipt. First is to scan the receipt and identify the boxes of text that appear on the receipt. The second is then, once we know the coordinates of the individual text boxes, we go ahead and read the text out of those boxes. And third, we then apply NLP to identify some context around whether the text that we have extracted is at a number which would qualify as an amount, or is it a date? So the two things you will see specifically populated here, it's going to be the date and the amount. So as you can see, the receipt has been populated. You can see a value over there, so let's go ahead and see what happened. So here you can see, we'll click on the image, you can see that we've identified the amount to be $73.82, and the date on which the expense occurred to be 9th of 2017. So that's pretty much it. That's pretty much lets us basically generate these expense line items. You can then click on it and say active a report, and that's kind of how you end up finding this expense reports. So that's it for me. This was the demo for how we have automated using filing expense reports.
So I kind of gave a hint of already of the solution of what we've done, which is basically where are the texts, what are the texts, and what do they mean? So we've used a combination of computer vision and NLU to extract and understand these texts from the scan receipt. To go into the deep details, I'll invite Henry to go into the models and the neural network layers. If I speak that, nothing will go through. So.
Hello. Is it working? Okay. Yeah. So the reason why we talk a lot about the use case in the beginning is because let me kind of give a story. I was talking to a friend and he was asking where you're working at. I'm like, I'm at Workday, and he's like, oh, isn't that website where I book my PTO with my manager? Why do you guys need machine learning? So what engineers don't tend to understand is that within a company, there's actually a lot of specific functionalities that can be automated or made more efficient by using not just software, but also machine learning. So without explaining the use case, it's kind of because there's a huge hype with machine learning right now and what it's capable of doing and what really is AI, right? Like is it going to succeed or is it going to fail, right? So we feel like giving a more concrete use case is actually something that is going to some indication of whether this field will survive in the future. I'm not saying it's in danger, but there's certainly always people that are doomsayers, right? So anyways, yeah. So the first problem is, where are the texts? And I think this typically how this is done in enterprise product is that you will manually create a bunch of templates that are fitting to specific merchants or wherever the documents that are coming from. And then you're going to run a statistics model on top of that and figure out which template is the most appropriate. And then you're going to extract all the values and maybe do some NLP on top of that, right? So that's the traditional approach. And then the next part is for us is, what are the texts? And the third part is, what do the texts mean? And we know that there's a lot of public cloud providers providing the first two parts already. But the last part, however, is very specific to Workday data and also the Workday product itself. So in the beginning, of course, we're not going to write all of that deep learning stuff ourselves. So we need to land upon a framework. And our requirement is that it needs to be very fast and agile in prototyping and experiments, because I think even up until now, I think you guys have seen the talks at NIPS and all that. A part of what you do with deep learning is it's being said as alchemy, although it's very debatable. I know you guys definitely disagree very, very much with that. But anyways, and the second one is, Workday is a JVM shop. So we want certain things to be productizable via Python, but also some on JVM where we can leverage a lot of the existing tools of a large company. And also we want the best accuracy, and our performance requirement is not as high, because what we want to provide as an enterprise product is that it has to work. It cannot be something where you tend to release the idea and then you gather some user feedback from the consumer space, and you're like, oh, somebody actually wants this, now let's go back and improve technology, right? So in the enterprise, it has to be reasonably well working. And then ideally, you want some support from the community that is building that framework itself. And again, I just want to say that we made this framework decision for this particular product in 2017. So whatever it is, I understand there are certainly enthusiasts of every framework out there. And if you're saying, oh, but that is not true anymore, sure, but this was back in 2017. Like, you got to be really careful what you say to the internet nowadays. Otherwise, next day you're on the Reddit and there's a bunch of people bashing you. So we picked MXNet comparing to, and by the way, at that time there's no PyTorch yet. So we picked MXNet over the popular TensorFlow because for our problem, and also for from a data scientist perspective, the imperative style, and I know that's also coming in TensorFlow right now. So so bear with me. And also for our specific problem, it trains way faster, consumes less memory, and also it has a better accuracy as well, which I'll show you in the next slide. And for some of our NLP and name entity recognition problems, we used a framework from AWS called Sakai. And it's essentially a sequence-to-sequence learning framework that is very easy to use. We were able to get an intern who doesn't know much about machine learning at the beginning to use it and understand the whole thing by the end of the summer. So, and also the author of this framework has been very candid in terms of supporting us. And when we started this, what we didn't expect is that AWS has because MSF is being backed by AWS, so they actually provided very strong support from their team inside of AWS to solve a lot of problems. So stuff like memory leak, which happens in a lot of the C++ based frameworks. Okay, now here's accuracy, right? So since we have to evaluate accuracy from a end-to-end perspective, and for us, what matters is if we're trying to get a number, we're trying to get a value, what is the perfect match, right? But then perfect match is a very harsh metric because if you get one word wrong, one character wrong, the entire word is marked as wrong. So at the same time, we also want to see edit distance. And again, this is in 2007, so we compared the two frameworks. And yes, we tried a bunch of different optimization techniques. We essentially did our due diligence in the evaluation, and MSN happens to have a way lower error rate. So after deciding framework, the first problem we want to solve is where are the texts? And we started using you only look once because it's pretty performant, and for our problem and our data, it works pretty well. But what we had to add on top of it is the angle of tilt. So the reason why we say we need this is if you're tagging a photo, you're tagging a face of somebody, like a portrait of somebody, and you're trying to figure out who that is. You just have to figure out where the face is. You don't have to worry about whether the person is, which side it is leaning, right? But for our product, it is possible for our users to take a photo while they're drinking their coffee, they're doing their expense report, or whatever it is. The photo cannot be tilted. And meanwhile, we're not going to say, hey, if you tilt it by 180 degrees, it's going to work, but it probably should work for maybe 10 or 20 degrees, right? So we added this specific output just to help us with getting the box in the right orientation. So we also used a ResNet instead of a convolution layer, which gave us some accuracy and training speed boost. Okay, the next problem is what are the texts, right? So this is a very well traversed problem, and a lot of people when they talk about reading text, they're like, isn't this what I did with the minus digits in the 80s? Well, sure. So it is well traversed, but what the solution we have now is based on Google's WaveNet, and we made a bunch of tweaks. So now I think the state of art for this is CNN plus BioSTM, which we probably want to explore in the near future. Okay, now this is the third part. This is the part that is very specific to the Workday product. So we have a bunch of different approaches for this, and the arsenal of the approaches are probably going to increase over time as we tackle different types of documents. And the first one is the good old rules-based. So there's a lot of hype about AI, but in the end, certain things are probably easier done using rule-based. And here we don't do resume-driven development, so we're going to use whatever works the best for a particular problem. So yeah, so it looks around surrounding context, surrounding words, and fuzzy regular expression. This is something you just hack given, hey, we come up with a set of rules, and then we analyze the errors and just basically refine the rules over time. And the next approach is what I was talking before, encoder and decoder sequence-to-sequence approach. So this is actually a LSTM with attention. And the vocabulary is just based off the training data. So this is specifically used when we want a particular field that doesn't have a very specific format. So if you're looking at total dates, there's a certain format associated to it. But for encoder and decoder, for fields that don't have a specific format, this is the method that we use. And there's a benefit to this approach, right? If you look at the receipt on the right, we all, as human, we all know this is an Uber receipt because it's black instead of pink. That would be Lyft. And we also, because you use the app, you can sort of see visually that this is an Uber receipt. But if you're putting this in machine learning, there's no Uber. So you can't just do any rule-based, you can't do any sort of like text selection and figure out this is Uber. But with the sequence-to-sequence approach that we used, we're able to figure out this is Uber based on not really the color of the header of the app, but the surrounding context and how the texts are arranged. So it's very interesting, but there's a downside to it. It requires you to have Uber in your training data. If you don't have Uber, it might just say something else that is pretty close, like Lyft. So that gives it a pretty big disadvantage, which is why we have another approach that complements this. And this approach not only uses context, the order of how the words are appearing, but it also looks at the location information of where the box of text appears. And then we use Word2Vec embedding to enhance the results. So with the two approaches, they kind of complement each other and give a pretty good result. So in the end, we have a bunch of techniques, right? Like how do we ensemble them together? If rules, well, we start with rules-based, and if we figure out that rules-based is not working very well, then we're going to turn into a perplexity-based solution, because in the encoder and decoder sequence-to-sequence solution, you're able to get a perplexity value of how well the model is encoding and decoding from one side to the other side. We can use that as a basis to do some sort of search on combining the rest of the two methods. So we're able to get significantly higher result from this ensemble. And then for many of our models, we did transfer learning because data is pretty hard to get in the enterprise world. So we have to, this is well known. You look at ImageNet, people do this all the time, but we pick words that are relevant to the words that we are going to look for, and we randomly stamp them on images. Okay, now comes what actually matters. Well, we have competitive results. I'll show this later with some slides. Essentially, we have a pretty harsh test metric that have really weird receipts and documents that some have handwritten all over them, and some have essentially like irregularities. But what this ensures us is that we're being very harsh on our models. So our production metric, and we got this from looking at how many of the expense reports done through this application that have been modified by the user, right? So we're looking at 95 of them have been not altered at all. And without mentioning a company name, let's just call it Public Cloud Company A. And I just want to make a disclaimer here. The document you're seeing here is actually not customer data. However, I have mimicked the behavior myself on Photoshop to create where the boxes roughly would be if we're using Public Cloud Company A's product. So now, if you end up joining us, I can show you the real data, but I am not lying, because we take protecting customers' data really seriously, and that's how enterprise works. But I can tell you, I did not purposely downplay, alter some of the results to make one company look worse than ourselves or the other. So Public Cloud Company A versus, so on the left it is our solution, and on the right it is Public Cloud Company A. So as you can see, it is missing a lot of information. Many things are not getting boxed correctly. Yeah, and now this is Workday versus Public Cloud Company not A. So this is a different public cloud provider. So this one tends to do a little bit better, but it has a quirk where it tends to miss smaller boxes, as you can see under VAT. And for us, this is actually a problem, because many times on receipts and invoices, you have the $sign, and they tend to miss it. But for us, it means a lot, because it tells us about the locale, the currency, and all of that associated information. But overall, though, I would say Public Cloud Company not A is definitely better, at least for our problem. comparing to the other alternative. And then we have some other examples too, where you can see the original receipt, and you can see that how certain approaches of finding the boxes tends to grab what is vertical more likely than some of the than our approach, which is more robust to that.
What about those false positives?
What do you mean false positive? Oh yeah. No, this showing is not really a demonstration of necessarily, and I mean this is only one document, right? So we can't really conclude that much from this one document. But the idea here is to demonstrate there is a benefit for doing your own models for a very specific problem, rather than using a seemingly generic solution that is provided by a large company. If we're really serious about this and getting all that metrics, we can. But and again, yes, there are false positives. Don't get me wrong. No, there's no solution that's perfect, right? But the idea is to demonstrate that it is possible for you to be on par with some of the large name solutions. So I hope that answers your question. Yeah. I mean, if you talk to me offline, we can discuss a lot more of the metrics details if I'm allowed to say it. But the idea is to show that there's value of doing this. Okay, so now I'm gonna hand up to Vivek.
Yeah. So all of this is cool stuff, right? So Henry and team explored using lots of data, came up with the models. Now comes the $1 million question: how do you put it in production, right? So how do you scale this for all of Workday's customers? So it's a simple, so it's more of a system engineering problem now. So I'm going to switch gears. It's a pretty straightforward system, but still has some, nice complexities to it, which make the problem and being an engineer nice and challenging. So essentially, what we have is a Kafka source, which basically has information about the image. So when you actually saw the demo where the image is being uploaded, this is what is going on in the back end, all of this craziness. So the reference to that image is in Kafka. We have a microservice that goes and gets it from an image store within the Workday production environment. And then we basically run through these various stages. So the first one is an ensemble of 3 models where we scale the image in different resolutions, and that basically FOI is field of interest detection. So that's kind of detecting where those texts are. The second stage is where basically you're reading the text from those boxes. So the input to the second stage is the coordinates, and then you're actually reading what the texts are. The third one, which is the parser, is what Henry was talking about. So it's a combination of multiple approaches. I've just shown it as a big block. And what we do at the end is then we get output from all of these stages, and we do a simple majority vote on what is most prevalent among all the outputs. What I'm showing below here is that each of these boxes we built. So what was fascinating was out of this came we kind of created a new machine learning platform within Workday. And part of that was essentially running MXNet as a service. So AWS followed us later where they have an MXNet model server now. But so all of this was done before they did a lot of those things. So MXNet model service is essentially takes a model in, takes the data in, spits out basically the output of what you're asking for based on the stage in which you are parsing that particular receipt. We created a model store, which is a part of our machine learning platform, and the parser and microservice also, which leverages the MXNet service. And then the result goes back into Kafka, and then it gets persisted back or read back to the mobile app that you saw in the demo that requested the results back. So all of this was, built to scale. The one thing I forgot to mention, Workday runs all its product in Workday-owned data centers, nothing in public cloud. The training and the exploration was done in public cloud, but nothing of this can leave Workday. So that's our MSA or Master Service Agreement with our customers, that your data will always reside in strong, strict controls within the Workday data center. Yes.
But don't you do share between the companies, like for like compensation?
You can repeat the question.
Right. So that's a different use case where companies or customers actually say that you can share my data with other customers. So that's kind of different. Even a lot of that code stays within the Workday data center. And there we explicitly ask the customers, are you okay with us sharing data with other customers? But by and large, most of it is within the data center. So, yep. So this is talking about the adoption rate of the receipt scanning piece. We launched it early last year, March of 2018. So this is basically out of all customers who use Workday mobile app to submit their expenses, we have seen a gradual uptick. So from a product point of view, it gives me immense pleasure to see this uptick, go on. And the second one is primarily for those who are using the functionality of scanning, right? We're seeing that it went up from 45% to 68%, where they are continuously adopting the automated way of submitting expenses as compared to manually typing in the expenses. So, so you can see that specific functionality or the specific deep learning functionality adoption rate is also gone up. This chart doesn't show it's showing a little flat, but I'll let you guys
Yeah, so
the numbers yourselves.
Yeah, it's 40 something to 68%, which is 50 something percent per year of increase. Yeah.
So again, and we have huge customers using it in terms of their offerings. Yeah. Now, all this didn't come for free. There were a lot of ups and downs. So some of the key learnings that we have in productizing this, building this so-called ML app development. I think Henry spoke a lot about this point and kind of illustrated. There's a lot of value in building models sometimes, specifically for your business use case. Especially in the enterprise space where customers are pretty, they're paying for something, right? So they want the accuracy to be pretty high. If a generic solution solves, great, good for you. In our case, that didn't work out. So we found that there was a lot of value in doing that. There was a huge gap when we started to productize some of these deep learning solutions in late 2017. Experimentation, prototyping, the mindset is completely different. The skill sets, the people doing it are different. When you start thinking of prioritizing some of these deep learning solutions, it's completely different. For example, when you're prototyping, it was done using GPUs. The Workday data center does not have GPUs, so all the inferencing was done using CPUs. So, scaling it appropriately to handle the incoming load, because per image or per document, the time taken has to be within reasonable SLAs to our customers. I think Henry mentioned this. We got excellent support from the MXNet team. We were one of their early adopters of MXNet in an enterprise space. So AWS went above and beyond in working with us in hashing out challenges that we faced in using MXNet. Especially we use the Scala libraries. So it's what Henry mentioned, it's Java, Scala shop, Workday. All the entire backend is in that. So we hashed out a lot of issues with them and kind of help them, at least the MXNet team, chalk out their roadmap in our favor at least. So, and the last piece, which is the data security and privacy piece. So we take this very seriously. So, data cannot be, outside of the application-specific use case. Customer data is protected within the data center, encrypted, right? We had to go, out of left field to even get the data for training, right? Because we had no receipts that we can take from the tenant. So we had to get creative. Like to give you an example, we had a receipt contest within the company where every Workday employee was encouraged to submit their receipts. And the one who submitted the most won an iPhone 7 at that time. I don't even know.
10.
10. Oh, okay. So sorry, I'm not an Apple person. So yeah. So we had to get creative. We got like 50,000 receipts or around that much. So that kind of formed as a ground tool for us. You know, we had to go out of left field again to get them annotated and all of that stuff. So it's a challenge, right? So it's not as easy as, you know, a customer scrolling down and customer agreement and saying, I agree. It doesn't work like that in enterprise. So you don't get data for free. So it's hard. And with that, I think, yeah, any questions?
So how